Morning, Jake.
Morning.
Morning, Bianca.
Unworthy, report to the main office. Kayla, Woody, to the main office, please.
It's unlikely.
You could always, most of the time it's a conversation.
You know, and interact with everyone.
I've only seen it happen one time, and that was because I had students for cheating.
Oh.
And I was not the only person that reported that.
Instances.
I have a question.
Yes.
So on the test, there was not a number 13 or 17, right?
Because
Because I asked Allie Grice too, because I was looking at it last night, because I thought I missed something.
And I've been having a lot of trouble with numbering.
Yeah.
Mr. Coffin apparently can't count.
I texted Allie, because Allie gets hers done a lot earlier than I do. And so I was like, Allie, I know you're finished, but like, did you do 13 and 17? Because this time you just send me a picture of the problem, because I do not have on my test. She's like, no, I didn't see them, and I kept refreshing it to make sure, and I was like, okay, I'm good.
Yeah, Mr. Coffin might have just not have put a 13 or 17.
I just got really scared, and it was late, so I didn't think the answer, you know. So I was like, hi guys. Are people on here already?
Hmm?
Are people on here already?
No, because Mr. Kaufman forgot to actually publish the unit. So we'll see as people jump in.
So like, do we have to do stuff on here?
Did you do stuff on the board before?
No, I mean like, examples.
We can pass it, please. And this is where I will be doing all of my work. Okay. You guys didn't come to the board before? Yes, this is a camera right here.
Oh, hi.
Oh yeah, Dawson's here. That's awesome. Hi, Dawson. I hope this works, guys. Hey, Dawson, in the chat there, tell me if you can read the board okay. Might as well be having a photo shoot.
Doing some poses. Y'all look at class. Thank you. Look at that. How many pages did it take you to do the test? Because it took me 5 whole pages. I'm so mad. It took me about 4. I was so mad. I was like, I'm going to get this all on 2 pages. It's just going to be nice. And then I couldn't.
I can write really small.
Oh, I don't. But I like spread everything out. So
Yeah, I don't do that either. I write like the next right.
I try to spread it out because I'm always anxious about like not being able to tell where the answer
Yeah,
is.
yeah.
Well, I like
really
start like box mine in or like do scribbles around
Yeah,
it.
just
Because then
box
it just
around.
messes me up if I don't.
So do you want us to have the live stream open so we
No.
can see when people ask questions, or are you just gonna keep checking it?
Well, in theory, somebody is supposed to come up and help us with that.
Oh.
Possibly in time, I might have one of you monitoring it yourself, but we'll see. Okay? We'll see.
So we don't need to have it pulled up?
No.
Okay.
If you pulled it up, it would probably start feedbacking.
Mhm.
And that's just gonna make for everybody to be uncomfortable.
Okay.
So,
You wanna take over my 2.6 homework?
I am sure that it's done. So, we're not gonna go ahead and do warm-ups here today. We are gonna go ahead and start right into Unit 3, 3.1. I'm gonna give us a few minutes here to let everybody join in online. Of course, yes, we are doing the live stream today. Here's hoping that this works and it's not an absolute mess. Should be conscious of what I say, as it's all now being recorded. Hello? I don't need both of you, I need one of you. DJ, sit right here and just let me know if anybody types questions in the chat thing, okay? That's literally all your job is. Okay?
Sir.
And let me know if it doesn't work or if they're telling me that it doesn't work, okay?
Okay.
So, we're gonna give this another minute or two. So here's the goal, of course, is that you guys, of course, are here live to see it, and hopefully they are too. Now, our students on YouTube right now, they are on a pretty significant delay. I'm gonna work with Ms. Whitlow about improving that time delay. They're about, I think, like 10 or so seconds behind, if not more. So we might have to go back to a problem here or there as they ask questions, and DJ will let us know. So just be patient, and I ask them to be patient as well as we're going through this. It's new, it's different, but it's the best I can offer you right now. Now, Bianca sitting there might be a little bit difficult to keep turning it back around to
Yeah,
look
I have the
forward.
slides pulled up on my phone.
So I do recommend that. Jake, same for you back there. And let me know if you can't see anything, okay? Are we all ready to begin? Mr. Coffin's under a lot of pressure because now everything I say is recorded, so now I can't talk like I normally do. I have to mind my P's and Q's because there will be evidence of me speaking badly about people. So, nonetheless, you guys on home, I do encourage you guys to get the slides up in one window and, of course, the live stream going on in another window. When you guys are in live stream, I don't really mind if you guys are like in bed. I don't care if you're in your PJs, but log on and be ready to take notes, okay? Let's go ahead, let's get into this here. So we are going to go ahead and start our first slide here, slide 3. Let's talk about extremes. So that's what we're going to be doing in this unit, is we're going to be taking and doing everything that we did from Unit 1 and Unit 2, and we're going to be talking about the applications of it. And the very first thing we're going to talk about today is extreme values, maximums and minimums. Now, we're going to talk about this in the terms of absolute maximum, absolute minimum, the highest point or the lowest point. We are going to be looking at this on a closed continuous interval. So we're not going to be going on and on and on forever. We're going to be looking at from this section to this section of the graph. What is the highest value? What is the lowest value? Now understand that there might not always be a single highest value. There might not always be a lowest value. And that's where our limits and our derivatives and those things are going to come into play. Are we all set here? Any questions in chat so far, DJ?
No, sir.
Good. Of course, there'll be about 10, 15 seconds behind. I'll have to see if I can play around with the settings to improve that. Okay, let's move on. So, when we're looking at these 3 graphs here, when I'm looking at these, the first graph, that linear graph, I have a very clear minimum point, a very clear maximum point. Very clear min and a very clear max. And those are absolute min and absolute max. When I look at the second one, there is a singular absolute max. There are two minimums, but only one of them is the absolute min. It is the lowest value, and it is at B. And then, of course, you see the next one where we have both of them. So what I'm trying to show you here with these three graphs is your min and your max. It's very possible that it could be the endpoints of our interval. It's very possible that they could be the endpoints of the interval. If I say it's going to run from here to here, it's very possible that where I cut that off could end up being the highest or lowest or both values. That's something that we'll have to keep in mind as we look at the first derivative test in a couple of days. It doesn't have to be those, and that's what I'm showing with the second graph and the third graph there, is that it can be values in between. So we're going to talk about how we find these, and that's what we're going to focus on over the next couple of days. That's what we're going to talk about with Rolle's theorem, the mean value theorem, and the first derivative test. Are we all set to move along? Going on to our next slide, slide 4. So relative max and mins. Relative max and mins. It is possible for a function to have both absolute and relative max and mins. A relative max is a peak, but it's not the highest peak. A relative min is same as the lowest point or a bottom out point, but it's not necessarily the lowest for the entire graph. Now, when we look at relative max and mins, it's possible that when I cut off my function, when I say we're only going to work here to here, what was relative becomes absolute in that window. Does that make sense? If I'm no longer looking at the entire thing, I might end up trimming it down to the point where a relative becomes an absolute. So it all depends on what interval we are working in. So the first couple of slides here, I picked this lesson on purpose to do our YouTube with, because this should be a relatively easy lesson for us all to do. In theory. In theory. So we're going to focus on critical numbers. That's how we're going to do this in calculus. We're going to do this first with some graphs, and then we're going to focus on the critical numbers. Critical numbers are going to be where the slope is 0. And if slope is 0, that means that the derivative will be equal to 0. The other option is that the derivative does not exist. We talked about that before, where if the limit doesn't exist, then neither does the derivative. And we also talked about how graphs come to a real sharp point don't work for derivatives either. So anytime that the derivative fails to be there, or anytime that our derivative is equal to 0, we will have a critical number. If you have an extreme value, you have to either have a derivative of 0, or you have to have a derivative that does not exist. All extremes exist at one of those two options. Does that make sense? Questions here? Concerns here? Issues here? So we are going to find extremes by finding these numbers and testing these numbers. That's the goal. In a nutshell, that's what we're doing for the next couple of days. DJ, how are we doing on chat?
You're good.
Good? Awesome. Thanks, bud. Appreciate you being in here with us today.
You're welcome.
Are you guys all set with this slide? Okay. So when I look at a graph like this one here, we should be able to do this just by looking at it, saying whether we have a relative or an absolute. Okay? So let's look at this one here. Where are my maximums and minimums according to this? And are they relative or are they absolutes? Take a look. What do you see? At what x value are we going to have a maximum? At what x value will we have a minimum? and then we'll focus on whether it's relative. Does anybody see one? X equals 0. What happens at x equals 0, Bianca? It's a maximum of the graph. Is it going to be the absolute maximum or is it a relative maximum? It is an absolute maximum. Where's a good example of a relative max? X equals 4. Very good. There's another one at negative 5. Those are all maximums. The only one that is an absolute is at 0. Anytime we have a peak, or we come to that sharp point that would be a peak, is going to be a critical number, is going to be a max. What about my minimums? Where are the minimums? Where are the bottom out points? At negative 3 and where else? 2. Are either one of those extremes? Are either one of those absolute? No, because I haven't cut the graph off. The graph is going down and down and down forever. So when I look at it, I have these as my critical values at negative 5, at negative 3, at 0, at 2, and at 4. We have a does not exist for our derivative for our first one at a peak. The rest of them all have a derivative of 0. That's what makes them critical values. When I look at the graph closer on the next slide, where I blow up the graph, you can see here that we circled all those points just fine. We identified them all just fine as relative maxes and mins, and our absolute maximum identified there too. Are we all okay with this graph? So you can see how we're going to test this. Now, first thing we're going to do is we're going to continue to do this visually, like we just did for this one. We're going to bring back some of our stuff from limits because it's a good thing to talk about them. And then we're going to move on to doing it with derivatives. So, when we look at an extreme value on a closed interval, when we cut this off, what we're going to do is we're going to find all these critical values between A and B, whatever we're going to cut it off. If we're going to say we're going to run between negative 1 and positive 5, that would be my A, and B is negative 1 and positive 5. We'll find all the critical values between the two. We are also going to test the two endpoints. As we saw earlier, we're going to test the two endpoints as well. If we look back on that previous graph, if I cut that off at the right spots, then those two relative mins would become absolute mins, wouldn't they? So we're going to double check those endpoints. We're going to double check the endpoints and make sure that they don't take the place as well. Once we find all of these numbers, once we have our list of critical numbers that we are going to run, we're just going to plug them into the original equation. We're going to go back to the original equation and we're going to test each of them. The biggest one will be our max. The smallest one will be our min. So the real challenge here is going to be gathering all of these critical numbers together. Gathering all of these critical x values together for us to test them. Questions here about this? Concerns here about our plan? I do recommend copying down everything on this particular slide. There's nothing here that we don't need. Everything on here is something that we are going to be doing as part of our pretty much everyday run here. Let's go ahead and let's move on. On to the next slide. Come on, there we go. So let's just take a look at these, and can you identify once again, like we did on the previous one from the graph, can you tell me where the extreme values are going to be? Can you tell me where those extreme values are going to be? What are our critical numbers here? Let's start with graph 1. What do we have? -3. What happened at -3? It's an endpoint. That would be a critical value, right? I want you to find the extreme values and where they occur. So is that -3? Is that an extreme value for me? I disagree. There's no point at -3. While it is the endpoint of my graph, I don't actually have the y value for -3. That's an empty dot there, isn't it? So that can't be my minimum. That can't be my absolute minimum. Where is my absolute minimum for this graph? At 0, at x equals 0. That's where my absolute minimum is going to be. That is my extreme value. What about a maximum? Do I have an absolute maximum for this graph? At 2. Actually, I think I have those a little bit messed up. Now, what is the actual absolute max? What is the actual absolute min? So what are those values? At x equal 2, we have 1. At x equals 0, we have -3. So the actual maximum here is 1. It occurs at 2.
So when you say find the extreme values.
I want you to tell me what actually is the maximum. Not where does it occur, not what x value does it occur at. I want you to tell me what is the actual y value we'll get out of this equation. Won't need you to. Extreme values should be absolutes. Let's move on to graph 2. Let's move on to graph 2. What do we have going on here? When I look at this closely for graph 2, I should see that there are no extremes here. We have some relative max, we have some relative min, but that's not the extreme values. The extremes are the absolute max, the absolute min. Questions about this one? Okay, let's look at number 3 then. You might be wondering why there's no min there, because it doesn't go down forever, but at the end point there, it does not exist. And while the derivative cannot exist, I need a point still. I need a y value still. There can be a sharp point and the derivative fail to exist, but I still need a y value there. Does that make sense to everyone? You can't tell me that the absolute minimum there is -2 because the graph doesn't actually get to -2. Let's go to graph number 3. When I look at graph number 3, I see that there's no minimum, or excuse me, I see that there is no minimum as the graph is going downward forever to the right side. On the left side, it looks like it's going towards a horizontal asymptote, but it's more about the right side of the graph, how it's going down forever causes no minimum, no absolute minimum. There is very clearly an absolute max, though. That absolute max occurs at 2. What is the actual value of that absolute max? What is it? It is also 2, right? So the absolute max occurs at 2, and it itself is 2. Making sure that we're clear. It's very possible that for me to twist the question and make it a little bit confusing, you have to pay attention to what I'm asking you to do. Am I asking you where is it occurring, or am I asking you what it is? They are two different things. Where it occurs is the x value. It's the critical number. What it is the actual y value we get from that x value, from that critical number. Let's move on. Let's move on. So, next slide, I got like 10,001 questions. 10,001 questions. A through M. All the things I can ask you to do about a graph. We're going to do this at least twice. Now, this is something that I have planned here with our live stream. I want you guys to go ahead and try your best to do this question. Fill these in the best you can. I have it right now. It's 10:30. So we're making real good time on everything. I'd like for you guys to go ahead and try this. I'm going to give about, let's say, 5 minutes to do this. So 5 minutes. I got 10:31 right now, according to my cell phone. So at 10:36, we'll go ahead and resume. Now, for those of you at home, it might be a little bit different time. But still, 5 minutes, and then we'll pick it back up. We might only do one of these because I don't want to bore everybody out of their mind today. Yeah, we're only going to do this one here. We're only going to do B. Let's take another minute or two. Let's see how far we can get with this. If I were you all, I'd put a little star next to this example. I'm willing to bet that you'll see something like it on your next test. I like this problem. I think it's a really good review problem, everything that you should have had done from pre-calc through what we've talked about now. Part of the reason why we're only going to do this one here, while we're going to skip the next one, is because Mr. Kaufman is getting antsy and wants to write on the board. And I'm sure that the people at home want me to start writing on the board too, because that's the whole point of us doing this thing here today.
Is the board show it like that on the stream?
Pardon?
How it's flipped?
It should, I think it's normal on their screen, but it looks mirrored to us.
Local means relative, right?
Pardon?
Local means
Yes.
relative, right?
Local is a different word of saying relative max or relative min. All right, let's start going through this. Let's start with part A, the domain here. Anybody have a good shot at our domain? Jake, you want to give it a try, sir? What do you got?
Bracket -5, comma 4, close parentheses.
Bracket -5, comma 4, close parentheses. So there are some issues with that. Only one.
All of that.
There's an asymptote in between there. So I like that you have the -5 with a bracket because it is a solid point at -5. I like the 4 with an open parenthesis as we do have no solid point there at 4. But we should put somewhere in there that x cannot be -2. So right after I finish that, I would put a little semicolon or another comma or something and write x can't equal -2. It can't be positive 2 either. Thank you. So I would also list that one out as well. Or another option is you could just do multiple intervals. You could say from -5 to -2, from +2 through -2, and 2 through 4, and use the correct parentheses and brackets there. That's the way I did it on the slides. But another alternative would be to put what Jake had, our bracket, our -5, comma 4, with the parenthesis, and we can put x cannot be plus or minus 2. That would be an okay alternative. At least by Mr. Kaufman's standards. I hope everybody at home can read what I wrote on the board. We'll find out in a few minutes when they tell us. So, let's move on. Let's do the limits here. We got a right-sided limit for 2. Who's got it? Coming in from the right side, where's the limit going to be at? -2. Okay. What about the other side? Where's it coming in to be? At 1. What does that tell me about the combined limit then at 2? It does not exist, which means that the derivative would not exist there either. Meaning that we have a critical value that we would have to test. Let's look up D. What do we see at D? What's the limit there? That one is, of course, 1. That's an easy one to point out, right? Okay. These are some ones that we've had some issue with in the past with different quiz problems and test problems. So I want to make sure that we're all comfortable here. The F value at 3 is what? Give or take what? -1.5. Maybe some of you say maybe -1 1/3 or -1 1/4. Just not -1 and not -2, right? Okay. The second part here, part F, is asking us what is the slope at that point, right? That's what it's asking us for. When you see the derivative, it's asking us for slope, and that should be +1/2. We are rising 1 and running 2 there, correct? What is this next one asking for? What is G asking for? The average rate of change between -5 and -3. What am I asking you to do here? Jake, you got a question or an idea?
Like the slope between 2 points.
It is asking you for the slope between these 2 points. What is the best way for us to do that? Yep, our bestest and good old friend, m equal y2 minus y1 over x2 minus x1. Now, as we'll talk about tomorrow with the mean value theorem, there's a much better way to do this for curves than this formula. This formula is very linear. When we talk about doing with curves, we're going to look at a better descriptor. Questions here?
I think Jonathan got a question.
John, what you got?
He said, how is C1?
How do we see 1? I'm not sure which one he's talking about.
How is C?
How is
equal
C
to
one?
Oh, how is
Oh,
C1? Okay, so we are approaching the limit of 2. We are approaching the limit of 2 as x coming to 2 from the left side. So when I look at the left side, I'm coming up from 0, that little bit right off the x-axis. The graph starts coming right back up. And even though the point doesn't exist there, it would be at 1. It hits 0 between 1 and 2. It hits 0 right about 1.5. So if we started thinking about it analytically from that point forward, we would go 1.6, 1.7, 1.8, 1.9. We're getting closer to 2, right? And as we get closer to 2, as we move towards that, we're getting back towards 1. I hope that answers John's question. I guess we'll find out in like a few minutes. Okay. What did we find for this slope there for G? Does anybody plug it in real quick and test it? Bianca says it's negative 1/4. Anybody can confirm that for us? I like negative 1/4. Okay, let's do the ones that we were just talking about today now. Let's do the ones we were talking about today now. What's the absolute maximum here? Is there an absolute maximum here? No. Is there an absolute minimum here? Once again, no. Right there at that vertical asymptote, we have some issues. That vertical asymptote's causing us some problems. We have no absolute max. We have no absolute min. Not on this closed interval. If we wanted to do that, we'd have to close it off even more. Is there a local max or a local min that we might be able to look at? I see at least 1 or 2. There is no local max here. There is no local max. There's no clear-cut peak or top of a hill. No top of a mountain, no top of a hill. What about a local min? Bottom of a V, bottom of a hill. Sorry, mine are a little bit out of order there. I do have a local minimum at 1.5, and that local minimum value is 0, right? So it occurs at 1.5, and its actual value is 0. That's why I have 0 up there. Questions here?
So endpoints can't count as local mins or maxes?
We would not count them as local mins and maxes because we don't know necessarily what's around them. We would count them as possibles for extremes on closed intervals, but when I look at this one here, not 5,1, negative 5,1, it could be a localized max for its side of the graph, possibly, but typically we're only going to look at them as extreme value options. Does that answer your question? Okay. Okay, increasing and decreasing. You guys love doing this in pre-calc. Where's the graph increasing? Where's it coming up? There's only a few places. Jake, you got one of them?
You want this one?
Yeah, just one.
Well, I wrote the first one, 1.5 to 2.
Yeah, between 1.5 and 2, that question that John asked earlier, right? That's where it's coming back up. That's the only time that the slope is coming up aside from the other section. Where's the other section where the graph is coming upward? Between 2 and 4, that bottom part there on the far right. Everything else should be a decreasing interval, right? Between negative 5 to negative 2, we are decreasing. Between negative 2 through positive 1.5, as Jake pointed out, we are decreasing. Questions here? Okay, now I don't want to do another one of these right now. I think I'll save it for a different time. I do like these problems. I really like these problems. I'm telling you right now to prepare for at least one, if not two, on your next test. There's nothing up here that you guys should not be able to do. There's nothing on this that you guys shouldn't have been able to do coming into this class on day one. Aside from maybe limits if you guys weren't in pre-calc this past semester. Okay, we're going to skip past graph C and we're going to move on. So, just as a quick reminder, this is what we're about to do. We are about to test and find critical numbers. We are going to do this instead of looking at a graph. Now we are going to do this with actual calculus. So, first I need to get something to erase my board with. And here comes the true test. Can Mr. Kaufman write neatly enough and large enough and dark enough so that live streaming is going to work? So now the pressure is on. So, just as a reminder, what we're going to do here is very simple. We are going to look for points where the derivative either will not exist or where the derivative is going to be equal to 0. So, when we look at this, that's what we're going to test, and that's what we're going to be. And these will be the values that are going to be our critical numbers. This is going to be where the max or min occur. We will plug it back in to find what the max or min is. So where and what? Two big questions here. Okay, let's jump into our first one here, which should be example D. Example D, we're going to find the critical points for this function here. We have the function f of x is equal to, we got 4x cubed minus 9x squared plus 12, no, is that plus minus 12? Minus 12x and plus 3. Okay, so the first thing we're going to do here is we are going to go ahead and we are going to generate our derivative function. You're going to generate our derivative function. So, the derivative, the first derivative of f, or 3 is going to come down and become a multiplier with 4, and that's going to give us 12x squared. The 2 is going to come down and be a multiplier with 9 and be minus 18x. And this is just going to stay as negative 12. The 3 goes away, correct? What have I made for you all? What type of function is this now? It's a quadratic. Guess what's on the board from Math 2 right now? Factoring. Oh, yeah. I'm so excited to bring it back. It's like we're back in Math 2 all over again. Quadratic formulas and factoring. It's going to be a good time. So, clearly the next thing we're going to do is we're going to set this equal to 0 and solve it. Set this equal to 0 and solve. And as you guys have already picked up, we're going back to Math 2 here. We're going to factor and solve when we can. And if we can't factor, we are going with the quad formula. So, brief reminder, I'm going to take out a GCF. 6x squared minus 9x and minus 6. I can take out a 6. Let's go back and take out a 6. You guys beat me to the punch. You guys beat me to the punch. I was going to ask, did I take out the best GCF? You already beat me to it. We'll take out a 6 instead. It's 2, 3, and 2. That's a much better quadratic expression. Okay? 2 fraction methods on the board in case you forgot how to do it. In case you forgot how to do it, I'm going to make myself a little factoring tree right here. A times C on this side. 2 times negative 3 is negative 6. There's not that many pairs for negative 6. Negative 1 and 6. Negative 6 and 1. Negative 2 and 3. Negative 3 and...
Isn't it 2 times negative 2?
Yep, Mr. Kaufman made another mistake. I'm nervous, gang, okay? Like, cut me some slack. I'm on the internet right now, okay? Negative 2 and 2. Negative 4. Whew. If it wasn't you guys, I'd be real embarrassed right now. These are our options. These are our options. Now that Mr. Kaufman can remember how to do factoring. Of course, we'll find the pair that we want, the pair that adds to be B. That's -4 and 1. Gives us our -3. Set up our two fractions. 2x, 2x, -4, 1. These ones reduce down. X minus 2. So my groups are looking like x minus 2 and 2x plus 1. So, carry this over. We have 6. We have x minus 2 and 2x plus 1. Brief review of how to do the two fraction method. Brief review on how to do the two fraction method. Set them both equal to 0. I'm going to get x equal 2, x equal -1/2, correct? So these are some critical values for us to test here then. These are some critical values. These are some x values of concern. These are peaks of hills or bottoms of valleys. Okay? Well, how do I know which one's which? How am I going to know which one's a max, which one's a min? Even if it is relative. Even if it is only a local one. Let's not overcomplicate it. Let's plug them back into the equation and see what they spit out. Go ahead and do so. Plug it in. See what you get. Use your calculator. Use whatever you need. Yeah, I bet we're going to want the calculator here. How's everybody doing at home? Hope we're doing okay. Questions? Issues?
You talk about when he's messing up.
Man, I'm glad I got support from them. Team, you done? No? Okay. When we plug them back in, we should get 6.25 and 25. Negative 25, right? Negative 25. Got my negative sign. Okay. So, what does that mean about these? Can we explain it? Let's tie it back together. What's happening here? What are we going to have? Let's put our answer right here in the center of the board. What are we going to have? Let's start with the max. Where's our max at? The max is 6.25 at 1/2, right? Negative 1/2. The min is negative 25, and it occurs at 2. If you want to think about it like coordinates, this is the coordinate negative 1/2, 6.25. This is the coordinate 2, negative 25. Questions here? Concerns here? Check the time here. 10:56. Doing good. Doing good. All set to move on. Okay then. Let's try this one out. Let's move on to the next one. For our next one, we have D. And we have 2 over x squared minus 4. So, over x squared minus 4. Okay, let's go ahead. Let's do this one together. I did the last one. You guys help me out with this one. It's the same idea. What are we going to do first? We want to rewrite it. How do you want to rewrite this, guys?
2 open parentheses x squared minus 4 plus parentheses negative 1 x 1.
Okay, so Jake says let's bring it out of the denominator. Let's make it x squared minus 4 to the negative first. Now, when I go to take the derivative here, we're just going to treat that 2 like a constant multiplier, so we're not going to spend too much time with it. So I need to focus on this part right here. This part right here to get the derivative. What are we going to use to do the derivative of that part? What was that, Bianca? The chain rule. The chain rule. Okay? So, derivative of f. The 2 multipliers, so the chain rule, we're going to do the derivative of the outside. What's coming down to be my new multiplier? The exponent that it currently is, right? So what's coming down?
Negative 1.
Negative 1. What's going to be my new exponent? Negative 2. What are we going to multiply this on the back end by? 2x, the derivative of what's inside. So let's put it all together. Let's simplify it down. We got the derivative of f is going to become negative 4x. That's all my constants being multiplied. Underneath, we're going to have x squared minus 1 quantity squared. X squared minus 4, my bad. Maybe their faith in me is misplaced.
And we did the quotient rule, that works too, right?
Pardon?
We did the quotient rule, that works too, right?
Yeah. If you go back to the very beginning and you decide to set this up as a quotient rule, you could do it that way. I think Jake's and Bianca's way of doing this is faster than doing a quotient rule. But yes, in theory, you could set this as f and g and go that route too, if you're more comfortable with it. It will take you longer, though. It will take you longer. Though time is less of a factor this year than it has been in years past. But that was absolutely an issue for students last year. Was I had, out of my class of 12, I had 3 students not finish test 1 on in time, so they ran out of time. And I had 5 students out of 12 not finish test 2 on time either. And test 3 was even worse. Test 3 ended up being a 2-day test. So, and then test 4 was online. So, nevertheless, we have our derivative. We have our derivative. What are we going to do with it? What do we need to do with the equation? We're going to set it equal to 0. What else are we going to do? Critical numbers occur at 2 points. When it's equal to 0, what else? When it does not exist. When will this not exist? When the denominator is 0, correct? More specifically, when x squared minus 4 is 0, right? So as we go to find the wheres, we're going to start by going, okay, when this is equal to 0, when the whole fraction equals 0, which of course is going to be when negative 4x equals 0. That's where our derivative, where our f prime is equal to 0. And then when it does not exist, and that's going to be at x squared minus 4 equals 0. Two options here. Okay, let's solve each one. What about this one over here? Where's that going to be? Of course, that's going to be at x equals 0, right? And just to make sure, if I put 0 back into my derivative equation, I am going to get a 0 on the top. I will get an actual number on the bottom, so it's going to be okay. When I go to this one, x squared minus 4 equals 0. That should give us two options here. It should be looking at x equal plus or minus 2. Plus or minus 2. Are we okay with these three values as my critical values? Now this time I have 3. That means that one of them is not going to be an extreme. One of them has to be a relative. So, like we did last time, let's plug them back into the original. This should be a little bit faster this time around. We're going to put in 0. By the time I'm writing them down, you might already have them done. We're going to put in 2. And we're going to put in negative 2. So for those of us following along, we got our derivative. Following along on our slides. We set the derivative equal to 0. Got that. We set the derivative then, the bottom of it equal to, where did I get a 2 from? Oh no, I plugged it back in. My fault. So, as we're plugging these back in, this one should be pretty easy. We're going to get negative 1/2. Correct? What happens with my other two? They don't exist. They don't exist. So I can't have a maximum, I can't have a minimum if it doesn't exist. This goes back to there's a critical point here. The derivative fails to exist, but it fails to exist because the limit itself fails to exist. Maybe at 2 and at negative 2 we have a break in the graph, we have a jump in the graph. Maybe we have a vertical asymptote there. We don't know. We could look at it and figure out. We could graph it in Desmos and figure out. So this is all we have. This is all we have. Questions here. We have a critical value of 0, and we have it at negative 1/2. This is our critical point right here, 0, negative 1/2. And without more information, we can't determine whether it's a max or a min. So we'll just leave it as is until we can fill in some more. Maybe we'll graph it afterwards to figure out what it will be. Maybe we'll go into some numerical analysis where we start making some tables. But for right now, this is going to be enough. I don't want to push our limits today with everything else I'm trying to do today. Questions? Okay, let's move on to another one. Move on. Find the critical points for this function. We have the function h of x and the cube root of x minus 2. You guys sit here, go on ahead, work ahead without me. You should be able to handle this at this point. And we'll work it together on the board in a minute. DJ, how's chat?
I'm good.
Good?
Yes, sir.
What are we chatting about?
Nothing really. Nobody said anything.
Nobody say anything. See a few of us still working here. You guys in chat, let me know if you can see that color or not. I don't know if it's going to show up.
He said it's good.
Okay. Are we ready? Let's go ahead, let's get into this. Callie, you shook your head that you're ready. Why don't you help me out here a little bit with this one?
I'm
Yeah.
ready for you to explain. I don't know
Yeah,
what to do.
Okay, let's do the derivative, Callie. First thing we need to do is rewrite this, correct? We don't like the way it is right now, so let's rewrite it. X minus 2, this is to the 1/3 power. Okay? Chain rule or quotient rule, but chain rule here. 1/3 comes down. That's my new multiplier, right? X minus 2 to the negative 2/3 now, correct?
Sure.
We subtract 1, and we're going to subtract it as 3/3. Okay? We would do the derivative of what's inside, but it's just x, and that would just be a 1, so there's actually no inside part really to do here. So when we look for our derivative, we got h, first derivative. We're going to have a fraction. This is negative, so it's going to come down onto the bottom, correct? Squared, cube root. So I got a 1/3 with the, on the bottom with the 3 there, I have the cube root x minus 2, 1 squared. That's what that 2 on the top is telling me, is that x minus 2 is going to be squared inside my root. Is everybody okay with this one so far? Okay. Where are we going to go now? What do we need to do with this? Say equal to 0 or find points where it doesn't exist, right? Okay? So what's the point where this doesn't exist? Let's start with that. Where's h derivative? Where does this not exist? Where's this d and e?
X minus 2 equals 0.
When the x minus 2 part of that root spits out a 0. Specifically, x equal 2, right? If I plug in 2, this square goes to 0, the root will go to 0, and 0 times 3 will be 0. Sets off that chain reaction. So we have one critical value. Is it possible for this root to actually, is there any point where h prime, h derivative of x, can it be 0? No, there's no value here that we can plug in that's going to reach 0. Because I can't affect change on the top of the fraction, which is where I would need to do it. So this doesn't happen. Questions so far? Concerns so far? Let's check with our slides here, make sure we're on track here. So everything looks good. So the derivative doesn't exist when the bottom goes to 0. More specifically, the x minus 2 part of the bottom goes to 0. Now, Maddie actually shortened that up a bit, and that was really good perception of you to realize that I don't need the entire derivative, entire denominator. I only need this part right here, correct? So, what are we going to do with it? What are we doing with it last couple times? Plug it back in. So we're going to go back to h of x. We're going to plug in our 2. Cube root, 2 minus 2. What do we find? It is 0. So we have a critical point at 2, 0. It's either a maximum or a minimum at that point. Questions here or concerns here? Can they see that lighter blue as well? I guess we'll find out. I tested these colors before, but I just wanted to make sure now that we're doing it live. Truth be told, the lighter blue and the dark blue almost look the same to me, but Mr. Kaufman's old, so can't trust my eyesight. We all set here.
Michaela says she can't see it.
Michaela says she can't see it. The lighter blue?
Yeah.
This is now a Math 2 marker only. All right, let's move on. Move on. Okay, so now we're going to do this on a closed interval. Now we're going to do this on a closed interval. So now we're going to be looking at where's the absolute max, where's the absolute min. So when I get this, we will have enough information that we're not going to be looking at just doing a critical point anymore. We're going to be able to say this is the maximum or this is the minimum of our function. So when we set this one up, we're going to start in a very similar fashion. We're going to start in a very similar fashion. We're going to start by getting the derivative here of fx. So when we start by getting the derivative of fx, we have f of x 1 plus quantity x plus 1 squared. Now, you can, of course, FOIL that out if you like, or you can just do a chain rule. Me personally, I would just do a chain rule. But if you want, you can FOIL the whole thing out. It's going to be x squared plus 2x plus 1. And then you could do the derivative from there, as my voice cracks like I'm still a teenager. I'm going to do a chain rule instead, though. F prime of x. The 2 is going to come down as my new multiplier. This is going to go away because it's a constant. X plus 1 to the first power now. And then, of course, the derivative inside would also be 1. So when I simplify my derivative out, I'm looking at 2x plus 2. If you want, of course, you could FOIL that out and do it that way. Like I said, you'll get x squared plus 2x and plus 2 once you combine all your terms. And then you can do the derivative if you're more comfortable that way. I recommend getting very comfortable with the chain rule, though, because as you can clearly see, it is not ever going to go away. All right, same steps as last time. Set this equal to 0. There's no point where this doesn't exist, right? This is always going to exist. This is a good function. This is a well-behaved function. So it's only going to be, when is this going to be equal to 0? And that, of course, is going to be where? Come on, now we can all solve it, not just Bianca. It's -1. So, doing the derivative has yielded me another option. There are 3 numbers we have to test here. We will test this one like we did on the previous problems. However, because I have closed my interval, I will also test the endpoints. My interval here is -2 through 5. And -1 is in this interval, so it's okay to be tested. If it was like -3, then I wouldn't test it because it's not in the interval. If it was 6, I want to test it because it's not in the interval. Does that make sense? We're only going to test critical numbers that spit back that actually apply to us right now. This one does. So when I set up my function, my f of x function, I'm going to test -1. I'm going to test -2. And I'm going to test 5. We need to test all three, the endpoints and the critical number. Those of us keeping up at home or on the notation there, as things pop up out of order apparently, that's okay. I see I have a typo on the slides. That's fun. Good job, Mr. Kaufman. At least I solved it correctly. It is 37. So, when I plug in my two endpoints here, which is what I have there in the green box, that's me plugging in my two endpoints. When I plug in -2, I get back, in fact, 2. When I plug this one in, I get 37. So right out the gate, this looks like it's my possible min and my possible max. The only thing that could disrupt this order is this critical number here. What does this spit out? This spits out 1. So since this is lower than our endpoint, that makes our endpoint not the absolute min. It means that my absolute min is going to be right there at 1. Oh, come on, let's cooperate here. So since x equals -1, and that's in the interval, we plug that in as well, and it spat out a lower value for us. So that's going to take the place, and that's going to be our absolute min. So I have an absolute min at -1, 1. I have an absolute max. I forgot to write min at 537. Questions here? I'm only concerned about the extreme values, so this is what we're looking at. Now, what we'll talk about later on in this unit is what does that mean for this one right here? What role does this play? Is this a relative max? Is it a relative min? How will we be able to know what that is? What are these other values that we don't use for the extremes? That's where our first and second derivative tests come in, and that's where concavity comes in, and inflection points, and all that other fun stuff we're going to be dealing with in this unit. Let's move on. Let's try the next problem. I did this one. I'd like for you all to try this next one without me. DJ, let me know if there's any questions about this one on the board. Okay? see you guys are just about finished up. So I'm going to go ahead and get started up here on the board. We are running low on time. We were doing good for most of class, and now we're running out. First thing we need to do is take the derivative of f of x. Of course, f of x here is going to be x cubed, 2x cubed, plus we have 3x squared plus 4. We're going to take the derivative here. We're going to be left with 6x squared plus 6x. We will then go ahead and find the zeros. There's no point where this is not going to be equal or non-existent. It's a well-behaved function. So we're going to go ahead and test our zeros here. So 0, 6x squared plus 6x. Well, I'm going to factor out my GCF here, x plus 1. That gives me two x values, x equals 0 and x equal -1. Are we all okay with what I have so far? Okay. Both of these values are in our interval, so we have 4 numbers to test, right? We have 4 numbers to test. When we test them out, we have the interval -2 through 1 with brackets. Let's be clear. Let's be clear here. If for some reason we have a parenthesis, would we test them? What do you think? We'll find out on the next slide. Okay, let's go ahead. We plug all of these in, so we're looking at f of -2, f of 1, those are my endpoints, f of 0, and f of -1. All of these need to go back in. What did we find here? When we plug in -2, we should get back 0. When we plug in 1, we should get back 9. Yep. We plug in 0, we're going to get 4. And we plug in -1, we're going to get what? 5. Okay? So, looks like to me, my absolute min is at -2, 0. It looks like my absolute max is at 1, 9. Questions here, issues here. Okay. Let's take a look at this next one. One where there's a parenthesis on our interval. Let's find out what we'll do with it. Let's find out what we'll do with it. Go ahead, give it a try. This might be one of the last ones we do here because I want to make sure I get plenty of time to wrap up everything here. I forgot, I don't think I took attendance. So we need to take attendance at some point here. Okay. Anybody want to help me out with this one? Not super difficult. That's what let me down here. Callie, you gonna help me out?
Yeah.
Okay. Callie, let's start by getting the derivative here, okay? What are we gonna do? What do we got?
I got 3x squared minus 1.
3x squared minus 12. What'd you do here when it came time to get some zeros?
I set it equal to 0.
Yep, and
I took out the GCF of 3 and I got x squared minus 4. And I set the x squared minus 4 equal to 0.
absolutely. And that gave us x equal to plus and minus 2. You do need both. Okay, now let's pay close attention here. Not both of those are in our interval here. We're not going to test positive and negative 2 because our interval is 0 through 3 with a bracket on the 0 and a parenthesis on the 3. So negative 2 is not getting tested. We will test f of 2 though. We're clearly going to test 0. Did you test 3?
I didn't test it.
We should test 3 too.
Okay.
We're going to test 3 too. Even though that endpoint itself is not necessarily included, that's more just about how we cut the interval, not so much the actual mathematics behind it. When I put in 0, I'm going to get back 0. When I put in 2, I'm going to get back negative 16. And when I put in 3, I'm going to get back negative 9. Okay? Well, it looks like to me that I have an absolute min at 2, negative 16, and an absolute max at 3, negative 9. Oh, no, not 3, negative 9. 0, 0.
If that had been the maximum, it would have counted since it's a parenthesis.
I would have still counted, yeah.
Wait, what did you ask?
She asked, Bianca's question was, let's pretend that that was 3 and positive 9. And that would then make it the max, right? Would I still count that? And the answer there is yes. The max occurs at 3, 9, even though I don't technically have 3 with the way I've cut my interval. Because what that'll still mean is that for the rest of the interval, all the y values still have to be less than 9. Even though I don't actually have 9 in my set, I still know that all of them have to be less than it. Does that make sense? Sort of?
Jonathan said, why aren't you testing 2?
Why am I not testing 2?
Negative 2. Negative.
Because negative 2 is not in my interval. My interval is 0 through 3, 0 through positive 3, and negative 2 is not in between 0 and positive 3. Okay, we are going to wrap it up here today because the rest of my problems are all just example problems and more of this, just drilling, killing, because I wasn't sure how much time to plan for, so I've made a lot of problems. You can continue to do them on your own. I think you have it figured out, it seems like. And the answers are, of course, there. So I would recommend you jump to the end here for the homework tonight. We're looking at page 169, and we're doing every other odd from 1 to 29. I'd also like you to do problem 39 as well. Those of you guys on the live stream, do me one quick favor. If you have any adjustments that you need me to make or want me to make, leave a comment or put something in chat there so that way I know to adjust for that. I know that there's a little bit of issue with Canvas this morning, so I'll make sure that that's more prepared for you guys next time around. I'm also going to see what I can do about the delay. And that's it. And I am gonna take this video, I'm going to put it up and leave it as on Mr. Kaufman's YouTube channel, so you can go back and rewatch what we did last. Okay? DJ, go ahead and end the stream there, buddy.